Well, hey there, chemistry students. Tonight's Chemistry Chaos episode 8 is all about polarity. Polarity. Alright, let's get started. Example 1. Polarity is the uneven sharing of electrons, resulting in a slight charge. That means the electrons are hanging around one or more atoms more than they are the other, causing a charge to happen on both ends, a positive and negative charge of the molecule. Alright, this can happen in two ways. The first way is when we have differences in electronegativity, meaning there's two atoms, one of them is more electronegative than the other, so the electrons hang around it more. This fluorine atom right here has an electronegativity of 3.98, which is the most out of all the elements. This hydrogen atom has an electronegativity of 2.2. 2.2 meaning that it's not as much as the fluorine. So all these electrons are going to be hanging around the fluorine a lot more, giving it a negative charge. Whereas the hydrogen is going to be lacking these, so it's going to have a positive charge, meaning more electrons means more negativity. Alright, the second way this can happen, and this is example 3, polarity can result when a shape of a molecule is uneven. Meaning, look at this water molecule. Water is polar because it's charged. The reason it has a charge on the oxygen so much more is because it's more electronegative. But not only that, it's got two poles of direction, which we call a dipole, meaning both of the hydrogens on the end are slightly positive, while the oxygen in the middle is negative. So you can see here two directions of pull, and this is what causes water to kind of, be very polar and erode things like canyons and such. Alright. Here's an example where we have a non-polar molecule. Even though there is a difference in electronegativity between the carbon and the oxygen, they are pulling in opposite directions. This means that the electrons overall are being shared evenly. Oxygen and carbon have a way different electronegativity, but all the electrons tend to hang around the oxygens much more. But they're in opposite directions, causing them to literally cancel each other out. That's why this carbon dioxide is, in fact, nonpolar. Alright. Well, in the lab, we will be doing an experiment that results around this example. Example number 4. Likes tend to dissolve likes. If you've ever dissolved anything that is polar into something that is polar, you tend to find out that they dissolve quite easily. Hydrochloric acid is a polar molecule. H2O is a polar molecule. And if we dissolve HCl and H2O, we get a nice hydrochloric acid solution, a dissolved solution. Well, what if they are not like? Well, oil is nonpolar, whereas water is very polar. What we get in certain cases, like this oil spill, is a non-mixing of the two, as in they tend not to mix or dissolve. Thus, the oil tends to float on the surface of water and wash up on beaches and cover cute baby seals, oh god! So, you get the idea. Likes dissolve likes. We'll be doing an experiment that's going to use this technique to help us determine whether or not a molecule is polar or non-polar. Alright, tonight's death metal band reference is Exodus!